small r from each other, they repel each other. Consider two positive point charges. So in the last class we have discussed that if we have similar charges like similar point charges, then similar charges like positive charges, positive charge, one positive charge repels another positive charge, one negative charge repels another negative charge. So we have discussed it that same type of charges repel each other. So here we are considering two similar positive point charges. Point charges means its size is just like a point. So there is first charge plus Q1, positive Q1, and second charge is plus Q2, means it is also a positive charge, and the magnitude is Q2. All right, then if we join Q1 and Q2 by a dotted line like this, if we join Q1 and Q2 by a dotted line like this, then, and the distance between Q1 and Q2 is small r. Distance between Q1 and Q2 is small r. Then positive charge repels another positive charge. So this plus Q1 charge will repel this Q2 charge because they are similar charges. Similar charges repel each other, and opposite charges attract each other. Positive attracts negative and negative attracts positive. So this Q1 will repel this Q2. So it will exert a repulsive force like this. It will exert a repulsive force like this. So the repulsive force will be, we will call it F21 vector. F21 vector means that the force is experienced on charge 2 and it is due to charge 1. Force is experienced on charge 2 and it is due to charge 1. All right. Now this Q2 will also exert a force on Q1. So it will repel it. The repulsive force will be here in this direction. So this force will be called F12 vector. It means that force is exerted on charge 1 and it is due to charge Q, due to charge 2. It is due to charge 2. So is it clear? Is it clear? Both the forces? Anusha, actually your screen got freezed. I'm not able to check whether you are there or not. Are you there, Anusha? Anusha, are you able to hear me? No? Okay, you do one thing. You switch off. You try to switch off your camera. You try to close. You try to switch off your camera. I think it is taking a little bit bandwidth, so that's why the connection might be a little bit disturbed. So what I have told you, are you getting it? Are you getting it?
I can hear you now. I could not hear what you were saying earlier.
Okay. So I'm going to repeat it. Please listen it again. This is plus Q1 charge. This is plus Q2 charge. So plus Q1 charge, this is a positive charge. This is also a positive charge. So positive charge is going to repel a positive charge. So force experienced on charge 2, force experienced by charge 2, and it is due to charge 1. That's why we call it F21. Force is experienced on charge 2. So we write 2 at the first place. And who applies this force? This charge 1 is applying this force. That's why we have written here F21 vector. Is it clear now?
Okay.
Is it clear? Again, let us see another thing, that this Q2 charge will also repel this Q1 charge. So force is experienced by charge 1 and this force is provided by this charge 2. This charge 2 is repelling this charge 1. So that's why we have written F12 vector. Force is experienced on charge 1 and it is due to charge 2. Is it clear?
Yes.
Okay. Okay, now we also come across a new term. You might have studied it in class 11th also, that there is a term called distance vector. What is this distance vector? Distance vector is from one point to another point. So if we are actually, the distance between q1 and q2 is r only, but if we are going to express it in terms of distance vector, which is also called displacement, then we write it as from q1 to q2, the distance vector will be treated as r12 cap. We will write it as r12 cap. We will write it as
I don't
r12.
understand why are we writing R12 cap?
Please wait for a moment. Please wait for a moment. हेलो, हाँ जी क्लास ले रहा था मौसी अभी, है ना? तो मैं आपको 11:30 या 11:40 पर कॉल करूँगा, 1 घंटे बाद। जी, काइट में हो गया, बहुत बढ़िया, बहुत ही बढ़िया, है ना? वहीं से बस भी आती है मेरठ से। बहुत बढ़िया, बहुत बढ़िया, बहुत बढ़िया। हाँ जी जी, नहीं ठीक करा। हाँ, हॉस्टल में नहीं छोड़ना, ठीक है। हाँ ठीक है मौसी, ओके, बाय बाय बाय। Actually, Anusha, whenever we go from one place to another place, so we write the displacement vector. Displacement, what is displacement? Displacement is one thing. If someone says that I am going to walk 5 kilometers, then 5 kilometers is called its distance covered by him. But if someone says that I am going from north to south 5 kilometer, I am traveling 5 kilometer from north to south, then this is called distance vector or displacement. So if we are moving from q1 to q2, then the distance vector will be treated as r12 vector, and and to provide direction to a magnitude, we write it as r12 cap. R12 cap is only unit vector. Unit vector gives us only the direction, and that's why we have taken it as r12 cap. The displacement vector, the unit displacement vector from here to here is r12 cap. Now have you understood about this? Now is it clear? Anusha, is there any network issue? Are you able to hear me?
Huh?
Are you able to hear me what I have?
Yeah, now I'm able to hear you.
Okay, I told you that whenever we go from one place to another place, like we are moving from q1 to q2, if we are taking this distance as the direction is q1 to q2, then we write it as r12 cap. R12 cap is unit vector from q1 to q2. Similarly, if we are taking displacement from q2 to q1, then we take it as r21 cap. Then we write it as r21 cap. Okay. Okay.
Yeah.
Okay. Now after this I have written here in vector form, Coulomb's law may be expressed as F21 vector. F21 vector is equal to force on charge 2, force on charge q2 due to q1. So force on charge q2, force is experienced on charge 2 and it is due to charge 1 due to q1. So it is equal to 1 upon 4 pi epsilon naught q1 q2 upon r square. R is the distance between q1 and q2. Okay, and whenever we put this arrow sign This arrow sign means that we are talking about the direction also. So what will be the direction of F21 vector? F21 vector's direction is here, from left to right. F21 vector's direction is here. And what is the unit vector? From left to right. From left to right, unit vector is R12 cap. So to mention the direction, we multiply it by unit vector. So we multiply R12 cap here. R12 cap, we will multiply it here. Is it clear? F21 vector is equal to this. All right. Now, let's move on to the next page, page number 8. Similarly, F12 vector. F12 vector. Okay, page number 8. On the first line is that R12 cap, we have mentioned what is R12 cap. So R12 cap is equal to R12 vector upon R. Is a unit vector. Is a unit vector. Is a unit vector in the direction from Q1 to Q2. In the direction from Q1 to Q2. Similarly, if we talk about F12 vector, if we talk about F12 vector, what is F12 vector? F12 vector is this, a vector which is in the direction, which is from right to left. This is F12 vector. So what is F12 vector? Force on charge Q1 due to Q2. Force on charge Q1 due to Q2. So how we will write it? 1 upon 4 pi epsilon naught. 1 upon 4 pi epsilon naught. The force will be the same. Force will be the same. 1 upon 4 pi epsilon naught. Q1 Q2 upon R square. This is Coulomb's law. So force will be the same, 1 upon 4 pi epsilon naught. This is constant, Q1 Q2 upon R square. But what will be the direction of this F12 vector? F12 vector is here, towards left. And towards left, what is the unit vector? It is R21 cap. So we will multiply it by R21 cap. Actually, this is called a unit vector. Unit vector means a vector whose value, whose magnitude means value, whose value is 1, whose magnitude is unit. Unit means 1. So we write it like this. We provide a cap onto this, R21 cap. So R21 cap provides it a direction only. Magnitude is only 1. So magnitude, this is the magnitude of this force. So magnitude will not get disturbed, but to give it a direction, we multiply it by unit vector. So R21 cap, we multiply it because R21 is towards left and F12 vector is towards left. Okay, I think now the complete thing might be clear to you.
I understand.
Okay. Now next we see the Coulombian forces. This is the force between the two charges. These are called Coulombian forces. Coulomb was a scientist on that scientist's name. The forces are also called Coulombian forces. The Coulombian forces between unlike charges Q1, Q2 is less than 0. Unlike charges means Q1 is positive and Q2 is negative. And if we multiply a positive term and negative term, then what will be the result? Positive multiplied by negative is negative. That's why we have written here Q1, Q2 is less than 0. Q1, Q2 is less than 0. It means that if both the charges are opposite, here we have seen that both the charges are similar charges, same charges, positive, positive. But if both the charges are opposite, then what to be done? Plus Q1 and minus Q2. Plus Q1 and minus Q2. Let's join it by a dotted line. Plus Q1 and minus Q2. We have joined it by a dotted line. Now, the distance between these two charges The distance will be r. Okay, now we will see, now we will check the directions of the forces. So direction of forces, first of all we will check the force experienced by charge 2 due to charge 1. So this is negative charge and this is positive charge. So what will it experience? It will experience that it is getting attracted towards this, because this is positive. Positive attracts negative. Positive attracts negative. So what this charge will feel? This charge will feel that it is getting attracted towards this positive charge. So the direction of force will be like this. Force is F2 because force is experienced by charge 2 and it is because of charge 1. So F21 vector. F21 vector. Okay. Again, what this charge will experience? It is a positive charge and this is a negative charge. So this positive charge will get attracted. This positive charge will get attracted towards this negative charge. So it will be like this. F force is experienced by charge 1 and it is due to charge 2. So this will be F12 vector. Now that basic thing will remain the same. What? Distance vector. Distance vector will remain the same. If we are moving from Q1 to Q2, then it will be called R12 cap. It will be called R12 cap. If we are moving from Q2 to Q1, then it will be called R21 cap. Okay, if we are moving from Q2 to Q1. Now we will write both the forces. First of all, we will write F21 like we have written in the case of similar charges. We have written F21 vector. Here also we will write F21 vector. So F21 vector is equal to 1 upon 4 pi epsilon naught. We have to take whenever we want to write the value of the magnitude of force, then we write the same formula, 1 upon 4 pi epsilon naught q1 q2 product of two charges upon square of the distance between them. So 1 upon 4 pi epsilon naught q1 q2 upon r square. F21 vector, the direction of F21 vector is here. The direction of F21 vector is here. So we will multiply it with which unit vector? This or this? Tell me.
Can you repeat that? R2, for F21, R12 cap, right?
No. F21 vector is here. F21 vector is now here. In the earlier case, F21 vector is like this. And unit vector along this direction is R12 cap. That's why in F21 vector we have multiplied by R12 cap. But here F21 vector is here. F21 vector is here. And in this direction, what is the unit vector? R21 cap. Understand?
R21 cap.
Okay. So we will multiply here with R21 cap. Similarly, when we are going to talk about F12 vector, F12 vector, then magnitude will remain the same, 1 upon 4 pi epsilon naught q1 q2 upon r square. But F12 vector is here and in this direction the unit vector is also R12 cap. Okay, Anusha, clear?
Yeah.
Okay. So what we have seen here that we are seeing here that what is the magnitude if we are talking about the similar charges also. What is the magnitude? F21 vector magnitude is 1 upon 4 pi epsilon naught q1 q2 upon r square. What is the magnitude of F12 vector? 1 upon 4 pi epsilon naught q1 q2 upon r square. So magnitude means value of the force is same, but direction is not same. Direction is not same. What is the relation between those directions? R12 cap is in this direction and R21 cap is in this direction. So whenever the directions are opposite, then what we write? You see at page number 8, we have written, after this diagram, we have written as R21 cap is equal to minus R12 cap, as R21 cap is equal to minus R12 cap, minus R12 cap. Therefore, F21 vector is equal to minus F12 vector, minus F12 vector. Okay, this means that the two charges exert equal and opposite forces. Equal and opposite. Opposite means we have expressed this opposite forces by this minus sign. Equal and opposite forces on each other. So Coulombian forces obey Newton's third law of motion. Newton's third law of motion: to every action there is an equal and opposite reaction. You understand this?
Yes.
Okay. Okay. Now next move. Second point is this: as the Coulombian forces act along F12 vector or F21 vector, that is along the line joining the centers of the two charges, so they are central forces, because the force acts along this line joining the two charges. Here also the force acts along the line joining. This force is not letting this charge, this repulsive force, this Q1 is repelling this Q2, then Q2 will go in this direction. It is not going in this direction or that direction. So they are moving. The forces are acting along this line only, line joining the two charges. So that's why we say that Coulombian forces are central forces. So we have concluded with the 2 points. First, F21 vector is equal to minus F12 vector. It means that Coulombian forces obey Newton's third law of motion. And second point is this: as the force acts along the line joining the two charges, therefore these Coulombian forces are called central forces. All right. Now, limitation of Coulomb's law. Limitations of Coulomb's law. So first limitation is this: the electric charges must be at rest. Electric charges must not be moving. Electric charges must be at rest. This is the first limitation. Second limitation: the electric charges must be point charges. If the electric charges are big charges, then this Coulomb's law cannot be applied there. So electric charges must be small charges, point charges only. All right. Next, third point: the separation between the charges must be greater than the nuclear size. Separation between the charges must be greater than the nuclear size. Nuclear size is 10 to the power minus 15 meter. So the separation between the charges must be greater than nuclear charges, because if it is less than 10 to the power minus 15, what is this? Anusha, you are not there in the meeting? Anusha, are you there?
Yes.
Okay. So let's move on to the next topic. Page number 9. Page number 9, permittivity. What is permittivity? Permittivity is actually permission. If we talk about any kind of medium, say open space or any liquid medium or any solid medium, then how much charges can move across that medium is called its permittivity. Okay, so page number 9, first of all, we will discuss about the definition of permittivity. Permittivity is a property of the medium which determines the electric force between two charges situated in that medium, which determines the electric force. So permittivity determines that what should be the force between the two charges in that particular medium. Actually, it depends on the medium only. Okay, then we will see relative permittivity. relative permittivity, the force between 2 point charges Q1 and Q2 placed in vacuum at distance small r from each other is given by the force between 2 point charges Q1 and Q2 placed in vacuum is given by, I am talking about this point permittivity, or relative permittivity. Relative permittivity. So F vacuum is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. 1 upon 4 pi epsilon naught Q1 Q2 upon R square. This is equation number 1. F vacuum, VAC means vacuum. So the force which exists in vacuum is given by this. We know that. We have seen here also 1 upon 4 pi epsilon naught Q1 Q2 upon R square. When the same two charges are placed the same distance apart in any medium other than vacuum, the force between them becomes, when we place the same two charges in any other medium other than vacuum, then the same force will be written as F medium, F MED medium is equal to 1 upon 4 pi epsilon 1 upon 4 pi. Now we will not write here epsilon naught, we will write epsilon. 1 upon 4 pi epsilon Q1 Q2 upon R square. This is equation number 2. Now what is this epsilon? Epsilon is the permittivity of another medium in which we are keeping these two charges. So epsilon is the permittivity of another medium. The quantity epsilon is called absolute permittivity or just permittivity of the intervening medium. Intervening medium, that the medium which exists between the charges Q1 and Q2. Alright, dividing equation 1 by 2. So if we divide equation 1 by 2, dividing equation 1 by equation 2, what we will get here, F vacuum upon F medium is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square upon 1 upon 4 pi epsilon Q1 Q2 upon R square. Look Anusha, both these terms are exactly the same, Q1 Q2 upon R square and Q1 Q2 upon R square. So it will get cancelled. It will get cancelled here.
4 pi gets cancelled too, and then you have epsilon by epsilon naught.
Epsilon naught, yeah. Have you got it?
Yeah.
It is epsilon upon epsilon naught. Okay, the ratio epsilon upon epsilon naught is called relative permittivity of the given medium. So can we move to the next slide?
Yeah.
Okay. This is called relative permittivity. Epsilon r is equal to epsilon upon epsilon naught. This is called relative permittivity. This is called relative permittivity. Now, on page number 10, we have two numericals. We have one numerical. We will do it. Please wait for 2 minutes. I am just coming back. Please wait for 2 minutes. Okay, let's check how to solve this numerical. So, two insulated charged copper spheres A and B have their centers. We have two insulated charged copper spheres. Charged copper spheres means they have some charge in them. A and B have their centers separated by a distance of 50 centimeter. So, they have their centers separated by a distance of 50 centimeter. So, question on page 10. So this is charge Q1 and this is charge Q2, and distance between them is small r, it is 50 centimeter. It is 50 centimeter. What is the mutual force of electrostatic repulsion if the charge on each is 6.5 into 10 to the power minus 7 coulombs? So given Q1 is equal to Q2 is equal to both the values of both the charges are same. So Q1 is equal to Q2 is equal to, say, Q is equal to 6.5 into 10 to the power minus 7 coulomb. 6.5 into 10 to the power minus 7 coulomb. So both the charges are same, Q1 and Q2 are same. That's why we have written here, let Q1 is equal to Q2 is equal to Q, and the value of both the charges is given to be the same. Okay, the radii of A and B are negligible compared to the distance of separation. So they are radii because it is given that the distance between the centers of both two charges. So the radii of both the spheres are negligible. Radius is very small, so it is negligible as compared to this distance 50 centimeter. Okay, so also compare this force with their mutual gravitational attraction if each weighs 0.5 kilogram. So they are asking what is the mutual force of electrostatic repulsion. Mutual force of electrostatic repulsion. So what will be the force? F is equal to, okay, they have not said anything whether these two charges are placed in any other medium. So whenever they do not say anything, whenever they do not ask anything, then we self assume it that both the charges are kept in vacuum. Okay, for vacuum and air, and free space, all these three things, vacuum, air and free space, charges, the forces of attraction and forces of repulsion between charges, they behave like the same in all these three mediums, vacuum, air and free space. So in all these cases we take it as 1 upon 4 pi epsilon naught. Okay, now F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So 1 upon 4 pi epsilon naught, Q1 and Q2 is Q. So it will be Q square upon R square. Okay. Is equal to, what is the value of 1 upon 4 pi epsilon naught? We have mentioned in the notes also. Value of 1 upon 4 pi epsilon naught is 9 into 10 to the power 9. 9 into 10 to the power 9. This is the value of 1 upon 4 pi epsilon naught. What is Q? 6.5 into 10 to the power minus 7. 6.5 into 10 to the power minus 7 whole square upon R is 50 centimeter. But we will not take it 50 centimeter as it is, because SI unit of distance is meter. So we will convert it into meter. So R is equal to 50 upon 100 meter. We will cancel 0 by this 0. So it will be 0.5 meter. 0.5 whole square. Now 9 into 10 to the power 9 multiplied by, what will be the square of 6.5? We will do it. 6.5 multiplied by 6.5. 5 5s are 25, 2 is carry, 5 6 are 30, 30 plus 2 is 32, one cross sign will be there, 6 5s are 30, 3 carry, and 6 6 are 36 plus 3 is 39. Okay, 5, 2 plus 0 is 2, 3 plus 9 is 12, 1 carry, 1 plus 3 is 4. After decimal, there is one digit after decimal, there is one digit after decimal. It means that in all, there are two digits after decimal. So count two digits from your right. 1, 2, it will be 42.25. So whole square, 6.5, so whole square will be 42.25. So 42.25. Now 10 to the power minus 7's whole square. So whenever we have power to the power, then both the powers gets multiplied. Minus 7 multiplied by 2 is minus 14. Now, what is the square of 0.5? The square of 0.5 will be 0.25. 0.25. Okay, here we are having two digits after the decimal, and here also we are having two digits after the decimal. Let's cancel both of them. All right, now, okay, Anusha, I just want to ask one thing, whether calculator is allowed in your exams in your school there or not?
I wish, sir, it's not.
It's not. Okay, then we have to do it like this only. There are two boards here majorly in India. CBSE board is there, and another board is ICSE board. Majorly convent schools are there they are affiliated with this ICSE board. In this ICSE board, calculators are allowed in class 11th and 12th. That's why I have asked whether there is some difference there or not. Okay, let's go by the normal division process only. So 25, if we want to divide it by 25, so 25 ones are 25. If we subtract 25 from 42, then it will be 17. 17, and this is 2, 172. So 25, 6 is a 150. If we subtract 150 from 172, we will get 22, and 22 and 5 is there, so 225. So 25 nines are 225. Now 9 nines are 81, 8 carry, 9 sixes are 54 plus 8, 62, 6 carry, 9 ones are 9 plus 6 is 15. 1521 into 10 to the power, when the bases of both the terms are same and the terms are getting multiplied, then their powers gets added up. So 10 to the power 9 plus minus 14.
So 1.2 into 10 is minus 5.
Minus 5. Yes. 1521 into 10 to the power minus 5. Okay.
Newton, right?
Yeah, Newton. Okay, we can do one thing. You always remember which the new concept which I am telling you. If you want to increase this power, if you want to decrease this number, if you want to make this number a little bit smaller, it is 1521. It is a big number. If we want to decrease this number, so we will count from here, 1 digit, 2 digit, 3 digit. We are counting 3 digits, 1, 2, 3, and we will put a decimal here. It will become now 1.521. So we have decreased it by 3 digits. Now we will increase the power by 3 digits, minus 5 plus 3. So we can write it like this, 1.5 into 10 to the power minus 2 Newton. Okay, is it clear? Now we will compare. They have asked in the question that you have to compare it with their mutual force of gravitation also. So mutual force of gravitation between Q1 and Q2. If you remember it, that we have you might have studied in class 11th, the mutual force of gravitation is G, capital G, m1 m2 upon r square. So gravitational force, we write it like Fg. Fg is for G is for gravitational force. So Fg is equal to capital G m1 m2 upon r square. So they have mentioned in the question. They have mentioned it in the question. Also compare this force with their mutual gravitational. I am reading the question again. Also compare this force with their mutual gravitational attraction if each weighs 0.5 kilogram. So each weighs means the weight, the mass of both these charges is 0.5 kilogram. So it is given that given m1 is equal to m2 is equal to m1 is equal to m2 is equal to m, and it is 0.5 kilogram. 0.5 kilogram. Then Fg is equal to G m1 m2 means m square upon r square. What is the value of G? You have to remember it, 6.67 into 10 to the power minus 11. What is m? 0.5. And kg is the SI unit. Kg is the standard unit of mass. So 0.5 whole square upon r. What is r? R is also 0.5. 0.5 whole square. So both terms will get cancelled from each other. Now it is 6.67 into 10 to the power minus 11 Newton. Okay. Now it is very much clear that this gravitational force is 6.67 into 10 to the power minus 11, and this is 1.5 into 10 to the power minus 2. So 10 to the power minus 2, out of 10 to the power minus 2 and 10 to the power minus 11, which term is smaller? Can you tell me? 10 to the power minus 2 is smaller or 10 to the power minus 11 is smaller?
10 to the power minus 11.
Yes, 10 to the power minus 11 is smaller. So we will write it clearly. Fg is smaller than Fe. Fe, what is this Fe? Fe means electrostatic force of repulsion. Fe, electrostatic, because when the charges attract each other and charges repel each other, then this force is called electrostatic force. Okay. Now let us see the B part, the second part of this question. So B part is, what is the force of repulsion if first part is there, each sphere is charged double the above amount and the distance between them is halved. Second, the two spheres are placed in water. Dielectric constant of water is equal to 80. Dielectric constant of water is equal to 80. Okay, so let's see how to do this. Part B, what is the force of repulsion if each sphere is charged double the above amount and distance between them is halved? So B part. Let's move on to the B part. Now Q1 dash is equal to Q2 dash is equal to, it is double the given amount. The given amount was Q, now it is getting doubled. So doubled means 2Q. And they are saying that distance between them is halved. So R dash is equal to R by 2. Okay, I am not writing any value. You can say that it is 2Q, then we can do like this, 2 into 6.5 into 10 to the power minus 7. We can do that, but let's wait for some time. I will show you how to do it more effectively, more efficiently. So when they are saying that the charge is getting doubled, so we are taking it as 2Q. When they are saying that distance is getting hard, then we are taking it as R by 2. Now, Now, electrostatic force of attraction. So, this is new electrostatic force of attraction. So we have written Fe dash. Fe dash. So Fe dash will be 1 upon 4 pi epsilon naught Q1 dash into Q2 dash upon R dash square. Okay. So Fe dash is equal to 1 upon 4 pi epsilon naught. What is Q1 dash? Q1 dash is 2Q. What is Q2 dash? It is also 2Q. What is R dash? It is R upon 2 whole square. Alright. Fe dash is equal to 1 upon 4 pi epsilon naught. 2Q multiplied by 2Q is 4Q square. And R by 2's whole square means R square. And what is the square of 2? It is 4. Okay, whenever we have terms like this, there is a numerator and there is a denominator, and we have a denominator of the denominator. So denominator of the denominator actually gets multiplied by this numerator. Okay, so Fe dash will be 1 upon 4 pi epsilon naught. When this 4 gets multiplied here, then we get 16Q square upon R square. Do not try to cancel out these terms, 4 with this 16, 16 with this 4, 4 the 16. Do not try to cancel out. We can write it like this: Fe dash is equal to 16 multiplied by 1 upon 4 pi epsilon naught Q square upon R square. Till now, is it clear what we have done till now? Anusha, is this clear till now?
Yes, sir.
Okay.
I'm writing.
Okay. Now, on to the previous slide, let's check. It was 1 upon 4 pi epsilon naught Q square upon R square, and we have calculated this. And the answer came out to be 1.5 into 10 to the power minus 2 Newton. Alright. So, we are not going to do this calculation again. We know that value of 1 upon 4 pi epsilon naught Q square upon R square is this, 1.5 into 10 to the power minus 2. So, 16 multiplied by 1.5 into 10 to the power minus 2. So 16 into 1.5, 16 5s are 80, 8 is carry, 16 1s are 16 and 8 is 24. So 24.0 into 10 to the power minus 2 Newton. Okay, is it clear? Is it clear, Anusha?
Yes, sir.
Okay. Now, let us check the second part. Let us check the second part also. In the second part, they are asking what is the if the two spheres are placed in water, dielectric constant of water is 80. Dielectric constant, what is this dielectric constant? Let me tell you. We have done one thing. Let's move on to the previous slide. We have done this thing, epsilon r is equal to epsilon upon epsilon naught. This epsilon r is also called dielectric constant. This is also called dielectric constant. Epsilon upon epsilon naught is called dielectric constant. All right. So F vacuum, write it as we know that F vacuum upon F medium is equal to epsilon upon epsilon naught is equal to epsilon r. This epsilon r is 80, bracket, I have written it in bracket, 80 given, and the because it is a ratio, so ratio do not have any unit. So we have to write it like 80 only. It do not have any unit. Now here F vacuum upon what is F medium? F medium is F water. And what is F vacuum? F vacuum is normally Fe. Fe. When both the charges were kept in vacuum, means free space or air, then we have taken that force as Fe. Are you listening, Anusha? And
Yes, sir.
okay. Fe upon F water is equal to 80. Now we want to calculate this F water. What is the force of repulsion when both the charges are kept in water? Okay, the new medium is now water. The earlier medium was vacuum. Vacuum, we have written the force in vacuum is Fe. So F water will go here and this 80 will come here. So Fe upon 80 is equal to F water. We have to calculate this F water. So F water, yani ki force in water is Fe. What was Fe? Fe was this 1.5 into 10 to the power minus 2. 1.5 into 10 to the power minus 2 upon 80. Now, if we remove this decimal, then a 10 comes here. And if we divide 8 10s are 80, 8 1s are 8, 15 minus 8 is 7. 15 minus 8 is 7. 7 0 70, 8 8s are 64. 70 minus 64 is 6. 6 0 60, 8 7s are 56. 60 minus 56 is 4. 4 0 40, 8 5s are 40. 1.875. 1.875 into 10 to the power minus 2, and we have 10 into 10. 10 multiplied by 10 means 10 to the power 2. So it will come onto the numerator, it will become 10 to the power minus 2. So 1.875 into 10 to the power minus 4 Newton. Now tell me, is it clear to you?
Yeah.
Okay, Anusha. So we will carry on from the next page. If I get time, I will take a class tomorrow also. Okay. If I get time, I will take a class of yours tomorrow also. Or otherwise, it will be on Saturday, as we mentioned earlier also. It will be on Saturday, means day after tomorrow. Okay. I hope all the things which I taught today might be clear to you.
Yeah.
Okay, Anusha. Okay.